All right, hello. This is the last class for Section 4, dealing with the carding game. And I think to wrap up the carding game, wrap up the semester, we're just going to look at what's happening with the higher levels, like the game managers. So let's just start opening them up and see how kind of the top level of this game scene is working. Let's see. So we have some. Okay, we have some scene management. So that must do with like load, like if you win or lose, or loading in another scene. We have playables. I'm not sure what those are. If that's descriptable objects or not, or if it's something with like those animation director tool, the cinema machine tool. But anyway, we do have like a custom namespace here that's coming from the carding game that the developer made. So we have an enum here declared at the top. The enum is called game state, and there's 3 states within it: play, won, or lost. And you could see that just arbitrarily given numbers, 0, 1, 2. And looks like we have some parameters sticking out here. End scene, load, delay. What scene are we loading when we win? The delay before fading to black. The delay before displaying the win message. Some sound to show. Yeah, set labels. This little icon right here means like that. That cinema machine, like it's like a director, like an animation director. Just want to find it. So remember, with a playable director. So these are like you can like animate the camera and like characters and the environment. So these are like cutscenes, like when you're not interactively playing, and so that's why it's like the director. It's like it's setting up. There's like animations that are being played, and it's not meant to be like an interactive situation, more like a movie situation. So that's what this thing is. Lose. All right, so we looked at the properties. That's what all these things sitting out here are for, and that's what this namespace was for. So, okay, this is our game state. This enum up here, like where are we? Play, won, or lost. So public get, private set. Okay, go out, get the player card. Looks like go out and get all the cards, including the enemies. I shouldn't call them enemies. I guess other carts in the game, opposing players that are AI. So on start, if auto find carts, so this was true. Go out and find anything of type arcade cart. So in this case, it's just me. There is like a training demo. Looks like the AI agents were trained on here, but they're not in the main scene, so I'm just going to ignore that. So there's only one of these, yeah, but it looks like there could be maybe multiple players or AI players that you're playing against. But if we have at least one, and we haven't found the player cart yet, just grab the first element in that array. And we're just going to assume that that's the player card, because in this situation there's only one element, but this is kind of not the best logic if there are others, but in either case. Go find the objective manager, the time manager. I'm guessing these are sitting up here as well. You get the objective manager, we get the time manager. Okay. Go set the master volume, go turn off. We have some win display, lose display. Set active, turn them off. Time manager, stop race. Okay. So we can open up the time manager. It's probably, it's bigger than I thought it would be. Let's see. You got some, is it a finite race, the total time, time remaining, restarted, and we have some events. So remember, actions are Unity actions, they're events. And they're static, so you can call them right from the class. You don't need like an object of time manager to reference. All right, on adjust time, on set time. So on awake is finite to false. Okay. I'm not sure if that's in regards to the actual like game level, like we were playing in a game level that's finite time. Try to figure out later. And then total time, which is public, we'll set that to time remaining. So what do we see? Well, it's not public, it's not being shown. Oh, okay, because we have our get and setters here. Somebody else must go in there and say, hey, what's the total time of the race or whatever, but we just set that to time remaining. On enable, when it's first turned on, okay, we're gonna, interesting. So when this time manager is first enabled, when the first time it's like turned on, it's going to say, hey, I've got these events that are affiliated to the class, not any instantiated object because they're static. And I want to listen to them. So it's like I'm an object of type time manager, and I'm going to subscribe myself listening to the class, my own class's events. And then when I'm disabled, I'm deregistering myself. So what are these methods? Adjust time. So a float comes in and gets added to our time remaining. Okay, it's like if you hit like a check mark or something and it adds like 5 seconds to your countdown, like you have extra time to complete the game. And then set time. So time is finite game mode. Okay. And these are private, so let me just make sure no one's inherited now. So inheritance. Okay, update. So if the race hasn't started yet, just return. Don't do anything. If is finite and we're not over yet, then take the amount of time since the last update frame and subtract it from time remaining. Okay, so time remaining keeps ticking down, just a small fraction of a second. And if time remaining is less than 0, then we're over. We didn't complete the game and the time has run out. So it's been negative. Let's just set it to 0 so it's nice and clean, and then say is over is true. And then somebody must be checking that. But these are public. Okay, someone's calling these start race and stop race. Okay. So these two that are private are only called when these events are triggered or invoked, and I don't see them ever being invoked. But maybe somebody comes in here and like invokes them at some time. Let me see. Yeah, crash object and pickup object actually goes right in there and adjusts it. Okay. So it looks like pickup object, time gained. So if you picked up a certain object, you add time, and whatever crash object is adds to it. So okay, they go into the time manager class and call this, and then that class, the objects gets these methods called. So adding time to time remaining, and so on. So interesting. All right. So let's go back to game flow manager. So time manager stop race. So all right. So what was this on start? We're saying, hey, the race hasn't started yet. Right? You can set the false. Sure. And for each arcade cart controllers, we set them that they can't move. So no user input. They kind of just sit there idling. And then run race countdown. So show race countdown animation. So this goes to the animator and plays it. All right, race countdown trigger. So that's that playable director. So this here. So this thing has an animator on it. Looks like it maybe gets assigned at runtime. The animator right here is empty. And when I click on it, like usually this animator will get filled out, but I can tell that this is dealing with the player controller animator. So take a quick look on the controllers. Yeah, we said player and cart. Okay, the playable director. Okay, so it has a playable race start. And within there's an animation. Perfect. Okay, recorded. So I don't know if I'm going to be able to play it back. But this is the animation that's being played. And when I click on it, what it's doing is it's going into 1, 2, 3. These are being scaled up. So it's kind of hard with an animation when you can't actually like play. It must be like in some other Unity scene or something, being able to play it. But these things are just being turned on and scaled up, where it goes like 1, 2, 3, and they're being scaled up. You can see this; their scaling is being animated. But it's kind of annoying that, like, how do you test your animation and play it? Oh well. Anyway, this is like giving that. This is running the play command on that playable director, and it's giving it the 1, 2, 3. And that was happening here, and we are still on start. And so start coroutines, these are interesting. So I'm glad we kind of stumble upon these. So coroutines are Unity's like offering or solution to multi-threading. So normally, like most apps or even Unity is what's called single-threaded. So you have these days we have multiple cores of our CPU. So we've talked about the GPU, the graphics card, right? And graphics cards specialize on displaying computer graphics to your monitor, and it's a separate processing unit, and that's what the shaders we're dealing with. And the CPU is where all of your code is run. So all the C# stuff runs on the CPU. And so that's where you have like the hard drive for long-term storage. You have memory, dynamic memory. That's for quick access, short-term storage. And there's other things going on, but if you think about just the hard drive and the memory, and then you have the CPU. So the CPU like grabs stuff from memory, grabs commands or data from the memory, and it runs them. And usually there was just like one core, meaning just one thread. You can only just run through this code line by line on one CPU, on one thread. And if for some reason something like has to wait or something, it like stalls the whole thread. So a common situation is when you're calling web requests and calling APIs, and you have to wait for a response. So if you're downloading something and you're waiting for the download to finish, or if you're calling a website and you're saying, hey, can you send me this data? But you have to wait for it. Or like when you, so in the situation of a game, you have to download assets and wait for them. So you don't want to like download everything to start with. So if you move from level to level, like on the phone, it might like download new assets, but you don't want to wait for it. So you want to do other stuff and give the user or player some opportunities to do stuff while you're doing other things, while you're downloading, while you're processing other stuff. So that's where multi-threading comes in and is popular. So if you need to wait for something, if you need to wait to see if like a web responds, you need to wait to see when an animation is done playing, you can do that off on another thread. You don't need to like block your thread, your main thread. So this is why multi-threading is really popular in modern computing. You know, it also means you get more power for your buck. You can run your scripts, like you can run on different cores. So if you have 4 cores, you could like potentially run like 4 pieces of code simultaneously. But this also introduces a lot of issues. Just know that, I guess, in modern computing, usually one thread is like taken up by your operating system, and the rest can be used, you know, as needed. So in Unity, coroutines are that multi-threading. When you start a coroutine, you're basically like, hey, go run this method off on another thread. Don't stop me. This calling method, this calling function. So this is like saying, hey, go run this method off on another thread. I'm going to keep moving on and doing other stuff and just ignore it. And it could like do whatever it needs to do on another thread. And when it's done, whatever. So anyway, start coroutine, show objectives routine. So if we come down here is the method. And then notice it's a little different. It's an enumerator. So it's not a void. It's not returning a void, an int, a float, a string, or whatever. It's actually returning an enumerator. So notice where it's coming from. Systems.collections.enumerator. It's coming from the operating system. So enumerators are a crazy computer science topic. I'm not going to dig in too much. Just know that it's a way for you to like run code on another thread, so it doesn't block your calling code. Your calling code is free to just move on and do what it needs to do. And enumerators, coroutines are really, in gaming, are used a lot for procedural animation. And let's see what's happening here. So the first one we do is start coroutine on show objectives routine. So show objectives routine. Normally this you'll see like this while loop type situation. So especially with like lerps. So like you'll start a coroutine and you'll like start lerping within a while loop. And the while loop is basically set up to be like, okay, run this forever until there is some like condition and we're happy and we're done and we could just like stop this method, but we don't know how long it's going to run for and we don't really care because it's not blocking our other code. So this is saying while the objective manager objectives.count is equal to 0, we're just going to yield return null. And then I'm just going to read through this first and figure out what's happening here. And then we're going to loop through and display messages and then wait for each second. Okay. So this is meant to, like, at the game start, you're given like a set of objectives, and it seems like later on you don't get new objectives. It's like it's a game level. At the start, there's some objectives that either you will win or lose by, and that's it. Now, what this first thing this does is it's just going to sit in this while loop. So this objective manager might not like be built, and it might not like set up its objectives and like be all ready to go for maybe a few frames or something. I don't know. But what this is happening is saying while the objectives collection, so it's a list, while the count. So when you want to know the size of an array, you do the length property. And when you want to know the size of a list, it looks like you do count. So it tells you how many elements are on the list. And so when we first start up the game, it's going to be 0. There's nothing yet. The objectives manager hasn't, like assembled itself, and it didn't go out and figure out where all the objectives are. So we have 0 objectives. So we're going to loop here and keep looping. So for like every frame, so like that, you can think that this line of code will be called now like every update frame. It's just not on our main thread. So if we did this here, this while loop like up here, not in a coroutine, we would just sit in it. Like it would just like stall the app. We would be like in like an infinite loop because we would never move on. We would never like move on to the next update loop. We would just like be stuck. So that's why we throw this off into a coroutine and we just move on doing our thing that we know eventually the objective manager will be built, will fill up with its objectives. But while it's 0, we hit this yield return null. So in enumerators, we have this like yield command. So it just means stop in this line. When you see this, basically it means just wait till the next frame. We're going to yield. We're going to yield our movement through this method. We're not going to move on to the next line of command, next line of code. So this is the benefit of using a coroutine, is that we can stop it. We can say, hey, we did our check, and if this is true, meaning we don't have any objectives set up yet, then while this is true, we're going to evaluate this line of code. And when we evaluate this line of code, it means yield. Just stop for this frame. So return null, basically it means saying like, we're going to yield, we're going to hold, and what are we going to hold for? And you're going to, when it's basically like saying, we're going to end this method for now, we have to return back something. So what we're doing is returning back null. And in the language of enumerators and coroutines, it basically means when you return null into this yield, it means just we haven't, nothing, no commands, just wait another frame. So yield is this special keyword along with the enumerator and this start coroutine. So all of this combined, these are like new keywords or new ideas. So you have to start the coroutine. That's a method itself, monobehavior.start coroutine. And you have to pass in an enumerator method. And notice you're calling it. So we're passing in a method and we're calling it. I'm actually on this one here. I'm passing in subjectives routine and we're actually calling at that instant. So here, and it's an enumerator. And this will be true when we first go in, and it just means, hey, yield, wait for a frame. And so we basically, each update frame, we keep going through this while loop, which is like very minimal processing. And eventually, at some point, this count will be greater than 0. So at some point, this objective manager will be built and get its objectives list, and this will be greater than 0, in which case this is false. So we don't go here, and we go here. And notice that the while loop doesn't have just like one line. If it's an if statement or a while or whatever, if it's just one line, you don't actually need like your curly brackets. But you notice it's like indented so that you can understand it's part of this while loop, and then you leave the while loop here. So what is this saying? While yield return, now we have something new. We're creating a new object, and we're calling wait for seconds real time. And this creates a yield instruction to wait for a given number of seconds. And so what do we have here? It's like a method, wait for seconds real time. Then you pass in how many seconds you want to wait for. And this is just 0.2 of a second. But whatever you pass in, say if you just passed in 3, this waits for 3 seconds before we continue on with the next instruction. So you can see how this is kind of useful. You can actually like give pauses as needed. For some reason, if we just want to wait 0.2 of a second, we want to wait a few frames. because who knows? And maybe it's more to say give a little pause for the user. We don't want to like jump right in and show the objectives. Like we want to give the user to start the game, maybe just give them like 0.2 of a second just to breathe a little bit, look around, and then we want to like appear these objective messages, and we feel like they're immersed in the game and they're ready to like read the objectives and be ready to know what they're about to do. So this is notice that there's a new keyword. So this thing returns something. We pass in a float and it's going to return back a yield instruction object, and then it's yield return, and it's going to return that yield instruction object which says wait for 0.2 of a second. So this string just pauses for 0.2 of a second, which is another reason why you want to off on another string. You don't want your main code, your main application, just not doing anything for 0.2 of a second, just stalled out. Nothing would even be like painted to the screen. You wouldn't even receive user input or anything. So once we wait, then we're going to loop through. We're going to do a standard for loop. Int I equals 0, I less than the objectives dot count. So we're going to loop through each objectives element. And if the objectives I, whatever this element is, so we should probably go and look at these objective elements, we're going to display message, this bool, this field is true, then we're going to call display message dot display. And then we're going to wait for a whole second and then call another objectives display. So you don't get like all the objectives thrown at you at once. Like every 1 second, one will fade up, fade down, and then another will come in. So let me just see. We have an update. We have an end game. Okay, but since we hit this objectives manager, let's see what's going on over there. Objective manager. So here's that list of objective. M objectives, M for member, private. And it looks like we have this property objectives, and whenever you referenced it, this is just, remember, this is the arrow function, the lambda function, which just says what this method has one line, it's just returning. When it's just one line and you're just returning a field, you don't even have to write return. You just use the lambda expression and you write out like the field, and it's implied that it means this is a very small method, and we're just, whenever it's called, we're just returning this field. I mean, it looks like we have a static event, register objective, on enable. This method gets registered to it. So whatever objective comes in through this, it just gets added to our list. All right, maybe we'll see that in action a little bit later. So are all objectives complete? Okay, if we have no objectives, return false. If we do have objectives, let's loop through them. And we have to look at what this objective object is doing, but if it has this method is blocking, then return false. Break the loop. Okay, this is interesting. We found one incomplete objective. We'll have to see what this objective object is like. But return false. So when you do a return here, you just leave this method. And they're saying that they break out a loop. There's no need to loop through anymore. If there are more objectives, we don't care, because there's still an objective that has yet to be complete. So we return, we leave the method, meaning we just terminate this for loop and we're done, and we pass back false. If we loop through them all and we never break out, we could just say return true. Yes, all the objectives are complete. All right. So who is, let me see, GameFlow Manager is calling that. Who, this is being called, okay, up here. So who, somebody is calling register objective. And it looks like the objective. Okay. So Who is an objective? I think these checkpoints are, right? Pick up object, objective time limit. Okay, so start finish line, lap object. So it's an interesting, sometimes I'll say, okay, there's this objective object. I'm trying to like figure out in the hierarchy, like who's using it. And sometimes you can right click and say, find references in scene. Great, nobody's using it. So it must be an inheritance thing. Let's see, objective reach targets. Yep, objective reach targets is inheriting from objective. Let's see, start finish line, lap object. I'm just trying to figure out what are objectives in this situation. Okay, lap object is inheriting from target object, which is, I don't want to say target object, it's objectiveness. No, it's not. Okay. All right, that's not objective. Let's see, are these checkpoints objectives? Let's see. Is there anything underneath them? Pickup object is a target object. Target object is not an objective. But you do register with objective. Alright, let's take a look at this lap object. You do register. And you're registering with your parent target object. And registering is, oh, these things are just calling the objective class. Interesting. Okay. This developer likes to have events that are class-based, not object-based. So, where was our objective? So, what we have here is we have this objective manager, and it just has a list of objectives, and it has this action called the class. You can just go to the class, say register object. That is actually an interesting way. You don't have to like figure out where the object is. You can just kind of call the class without worrying about where these component objects are. So that is an interesting approach. Okay. And who is registering? So one way that this is working is like we have this objective time limit right here, objective reach target. And this thing is inheriting from objective. And so on start, enumerator. If I want to say that start method can be, let's double check. I don't want to say something be wrong about it. Just need a second. Okay, there's a lot going on here too. I just wanted to, but what I wanted to see was what's its start method looking like. Because it's enumerator start. Yeah, it's still a unit. It's still coming from mono behavior. Interesting. So it looks like, yeah, I get something right. So this is a start. This is a start method that is called, that you're familiar with, that like if it's a mono behavior, you have start, non-enable, and everything. But it looks like instead of void, it's an enumerator, which you could do as well if you didn't want it to be a normal start method. And it looks like what they're doing is this objective reach target. Like this is the objective that like is time based. Like you need to like go around the lap before a certain amount of time. All right. So it goes out to the time manager on set time. So it's an action on set time. Yeah, it's this one. So it calls it. So I just want to make sure it's not another on set time. Now it's set time. Interesting. So I'm used to like invoking events, but it looks like you can also just call it like a method. And what it's doing is it's passing in this int pool in this game mode. And then whoever's listening to it, for example, set time here is listening to it, like these three numbers. That's interesting. So this is another way you can call. You don't have to just call the invoke on it. You could just call it like a method. So anyway, it sets the time, and then it waits. So wait for the end of the frame. So this is another type of yield instruction. So basically, you can wait till everybody else who's processing code on start, wait till they like do everything, and we're all the way at the end of like the start frame, and then the rest of this code will be done. So it's kind of like a late start. It's like creating your own late start. So the title, some string, must be an objective. Yeah, there's a title here. So is this. So collect plus, and they have like the ternary operator right in the middle of this. Must collect all pickups. So this is true or false. If it's true, we add this string. Otherwise, we take this integer and cast it to a string and add that to it. So collect all the or collect 3. So it's either one or the other. That string becomes, and then add a space, and then add the target name. So collect all the pickups, or collect 3 rings, is what the title would come out to be. And then if must collect all pickups, then this integer equals number of pickups. Okay, and then register. And I believe this register was over here in objective. Yeah, register. Protected, only itself or its children could call it. Sorry. What is an enumerator? So an enumerator is, so I said it's a computer science term. We're not going to get involved in it that much because it's not that useful knowing like dictionaries and stuff. But it's an evil hack. You could think of it as like it's a way to stop it. It's a way to I don't know if I'm going to find a good graph for this, but like a lot of data collections are behind the scenes. They're enumerators. So they're inheriting from this type of this interface enumerator. And notice it was coming from like system.collections. So something that could be enumerated, something that has like elements that can be moved over. So when you like loop through an array or loop through a list, the only reason you can do that with this system.collections is that it's because all of them are coming from the enumerator interface. They've built in to their objects ways that you can move through their elements, like step by step. So dictionaries, lists, maps and graphs and stuff like they're all enumerators or enumerable, meaning they're a collection you can move through them. And so then the reason that coroutines kind of are of the same nature is that you can step through the frames, kind of you can yield and wait, and so it's kind of like a collection of frames. You can kind of move through the time sequence, and the code can know when to like start and stop based on those yield commands. I don't see a good image, but if you did want to read up on it, there's I can see there's tons of people talking about it. But notice here, like enumerator, so enumerable, like collections that are countable are coming. This is like an inheritance. So collections are inheriting from enumerable, and then dictionaries and lists are inheriting from them. So how do you handle a collection of data? They have to be countable. You have to be able to enumerate, have like distinct elements of them. So anyway, the reason that coroutines are enumerable is that that's how they can kind of stop and pause it, and they're like counting the frames, the time, because they're on like another string, and you can manage when to run the code or not run the code based on yield commands. So on the objective, when we're registering, it looks like we're going up to the manager and we're calling register object. So here, all that I have to trace back to get to this. So you can say, you can pass in your objective object and it'll get added to the list. So there's a lot more stuff going on here in objective, but I just wanted to get like the gist of where we're going from, like this objective reach target, or even what are on different these rings, these checkpoints. I forgot what the script pickup object. Even though this is not inheriting from the objective class, what it does is it calls register, and what this does in target object is it goes to the objective class, not the object. So notice how the objective class has these unity actions, the static ones here, and you could just call it right on the class. So it's like this lap object, which is inheriting from target object. It's like it kind of is functioning like an objective, but it's not inheriting from objective for whatever reason. But it can go to the objective class and say, hey, on register pickup, invoke. So here's more traditional. Here's an invoke. This target object, this instance. So it'll go to objective and call this, and then who's listening to this? Probably the objective manager. Register pickup. So register pickup here. So this gets passed into here. I see, and then it gets added to this pickups list. Okay. Objective.pickups. So I guess pickups and objectives, the objective are not part of the. We have this pickups list on an objective. Sure. So we have a list of objectives up in the objective manager, and then we kind of have this like list of pickups. So I guess once this, as if another objective is managing like how many pickups are there, and they can look at this pickups list, which should be static. It's not. It's for the object. Okay. So let me go back to the game manager, and ultimately we have this objective manager. So then are all objectives complete? So the game flow manager was here. Okay, so we're back in this update. Okay, so I went through this enumerator, show objectives, routine, basically that, and then this led me on the path of looking at the objectives manager and how does it register all of its objectives. And anyway, it starts printing out these objectives on the UI, which we can look at that. But let me finish. Once we're done with that, or we move on once we ran that start routine and we go to this countdown, then start race. So all it does is it's an enumerator. It waits for 3 seconds, and then start race is called. So here's start race. For each arcade carts, we can tell them to move, and then the time manager says, okay, yes, we've started the race. All right. So this is what's happening in this update loop. So void update. If game state is not game state play, what else could it be? Won or lost. Okay. So we go right into play, it looks like. So if we're not in play, we've either won or lost. And elapsed time before end scene. So we take all the little frames of time and we throw them into this elapsed time before end scene. And when this gets greater than end scene load delay, which I think was like 3 seconds or something out in the inspector, then float time ratio 1 minus time load and game scene minus time. Okay, time load. Okay, this is something, maybe it's like a no, this should get set somewhere. Yeah, it's getting set here. Okay, so this is all endgame. So somebody's calling this endgame. 143, 146. Okay, so let me say, let's just say we're in play mode. So this would be, are we not in play mode? No, we're in play mode. That's false. So we come down here in our update loop pretty often. And then it goes out to objective manager. Are all objectives completed? And we reviewed that. And if that's true, then end game, they call end game true. Or another if that could happen is this a finite game? Okay, so is finite must be that this game level has finite time to complete it. And we've passed our time, then end game with false. So bool, winner. Have we achieved all the objectives within the time frame, or has the time gone too long? True false comes in here. In either case, lock the mouse cursor, stop the race, the time manager, so stop recording the time. Game state, is this bool that came as a win? Then we set our game state to 1, otherwise lost. Fade up some canvas group, like fade up like a vignette or something. Change the UI. If we won, here's where this is set. This was set with the current time plus however it takes to end scene, the load, the delay, plus the fade to black. So add this all up plus our current time. That's when we know that we should be done. Play some audio, display a message. If we didn't win, if it's lose, these are the same. Just show a different message, a lose message. So in either case, we would go through the update loop and we'd hit here. And we're not playing, it's either won or lost, right? So then we hit this, and we keep cycling here until this gets bigger than whatever this is, 3 seconds or whatever. And then we say, okay, how far are we before completely ending it up? So this was calculated down below. Take whatever that is, subtract our current time. So say if like we're currently like 33 seconds into the game and it says, hey, we should be completely done at 35. So it'd be like 35 minus 33. We still have like another 2 seconds left. and how much of our completely load. Let's just say the whole process, the whole ending process is 4 seconds. So 2 over 4 is a half, and then 1 minus that half is a half. So let's just say it's like saying how far along are we. In this case, in that example, would be halfway along. And that's whatever this like fade up, fade to black. So it's halfway fading up because we're halfway through our time. And then take this time ratio and take the absolute value of it. I guess in some of these situations it might be negative or positive. And that would create this volume ratio, and then we clamp it, do 1 minus that, and we clamp it between 0 and 1. And that's like our audio. So this must be also how it's like ramping up or down the audio. I guess if it's 1 minus, it's we're like ramping it down. We were at like full volume and we're going down to 0. So, so these are what you could, I just wanted to, this is kind of what you could consider procedural animation. We're ramping up the blackness, the alpha of our UI. We're like fading to black. We're changing this black ratio over time. That's procedural animation. And we're like fading down the audio over time. That's also what you might consider. Because procedural animation is just like changes in component properties over time. Usually the changes are so small in little fractions of a second that it looks just like smooth to your eye. And then see if it's time to load the end scene. All right. So if time is greater than this thing that was computed, then we go to scene manager, load scene, and load that the win or the loss scene, whatever we figured out. And then we set this to play, which maybe if we hit restart or something, and we want to be in play state, but I don't know why I set this at the end. All right, that was end game. That was the update. So there's a lot. There's a pretty complicated game flow manager, and the objective is managing whether we have objectives left to complete or not. And we looked at the time manager, which is just keeping track of how much time we're moving through, and if there's like a set amount of time, are we close? You know, did we go over time or not? And that's if you get time added to it, adjust time. Cool. I don't know what the prefab replacer. I mean, pool initializer. I mean, I look at this quickly, and I think I might be done because pooling is an important concept. Pooling means instead of creating and destroying game objects at will at runtime, which is very expensive, you might say like, hey, we really only need 50 bullets at any time when someone is shooting like an automatic weapon. We've figured out the math, and like really they're never going to go over like 50 bullets on the screen at a time. Or number of enemies. Just because you're running through a level and you're fighting like enemies over and over again, like 1,000 enemies, maybe the way the game is built, you're really only fighting 10 at a clip. So why not just pool up, create 10 enemies at runtime, and then turn them on and off and like place them. Keep track of who's alive, who's dead, and just resurrect them basically and move them to another location. You don't need to keep creating, destroying enemies. So take a look at pooling. So it looks like we have pools. Okay, so they're pooling all these notifications and objectives and win game messages. It's like all this UI stuff. You don't want to be creating and destroying it as it's popping up. So this is a good use of like, here's a bunch of prefabs that the UI is going to use over and over again. Just turn them on and off, and change their settings, change the strings in them. But we don't need to be constantly creating and destroying stuff. So these are the types of elements, the type of prefabs that we're going to be interested in. We have 6 different types of prefabs that our UI can use. And that's what this pool object definition. So there's a different class. It's interesting. Let me just take a quick look at this. Okay, so this actually moves us into scriptable objects. So that's actually, let me just take a quick look at these. Okay, so these are scriptable objects. Yeah, let me talk about them briefly because that was actually something. Just want to see if they're up here real quick. No. Okay, so notice it says .asset, right? So scriptable objects do not live as components. They just live in the assets, the project down here. And basically, they're super useful when you're working with designers or non-techie people where they can like change stuff. So they can, like in this case, we're saying, hey, in this pool initializer, we know that one of the things we're going to need a lot is this notification prefab. But notice it's referencing an asset, not the prefab. Now, what they did was this right here is a scriptable object. Notice it's inheriting by scriptable object. It's a C# script that somebody wrote. And first off, you have create asset menu. That's what I was looking for. Pool object. So you can actually, under assets, create pool. Notice up here, they created like their own custom menu items, which is really cool. So somebody can come in who's not a programmer and say, okay, I want to create a pool asset that's of type object. All right. And when they do that, it's going to create an instance down here. Like these were created from that. So these are coming, that's why it says it's a pool object definition. All right, somebody wrote this, and you can go up in the assets menu and create it, and it creates them down here. Like I'll just create one real quickly. Oops. Create pool object. See, new pool object definition. And then you would name it, and then you'd set all these numbers in this pool, and you would say, what's the actual prefab that you want to create or reference with this? So default spawn count, how many should be created? Oh, that's awesome. How many of these prefabs should we create at start? How many spawn this many objects in one go if the pool? So if our pooling ever runs out and we need to create more in the middle of the game, how many should we create at that instance? So let's create another 3 if we ever run out of our pool. Meaning they're all in use, we have none kind of in passive storage. An object parent must be returned to reuse it. If false, object will be reused if disabled. So return to parent to reuse. Object parent must be returned to reuse it. Let me read what I'm guessing. The object will be, so if you turn the object off, it's like eligible to be reused. Otherwise, you need to return, when you're done using the object, if you return a reference to its parent, then we know that we can reuse it. The prefab that this pool will spawn. So what is the actual prefab? So notice this is a game object. It's a real prefab. And then down here, we have some private stuff. So a list of this game object's pool and who its parent is. And then we have some code here that I'm not really interested in looking at the code at the moment because this example of like notification prefab says at the start we're going to spawn 4 of them. If they're all used at a moment's notice, so we don't have any others, all right, we're going to take a hit to processing and we're going to create another 3. And this is false. This just means whenever they're deactivated, disabled, they are eligible to be respawned. They are in the pool. They are able to be reused with new content. And this is the pool. This is the actual prefab, the actual like UI prefab that we're going to use. So this is really cool. So we have pools. If we go all the way back to our pool initializer, which is a component object, and it's saying, hey, I want to make an array of these these pool object definitions, call them pools, and make a new one that's the size of 0, an array of 0, because it's just empty. And then the user, whoever, can just add. See, it's at plus or minus. You can add more elements. Right now it's at 6. So there's 6 pools. So you have to understand each of these scriptable assets are saying, hey, I'm basically managing one pool of prefabs, another pool of prefabs, there's 6 pools of prefabs that would be reusing. All right, and then who's your parent? That was just a game manager. And on enable, you initialize. So destroy it in case there's a bunch of hangover stuff from another scene. Just destroy everything, and then loop through and go through each pool and initialize each element, each pool of elements. And so from there, we would go into each pool. So each pool is this pool object definition. And so remember, this is a scriptable asset. It's not in the game. And it's saying when we initialize all, so here's an assert. Basically, hey, if I don't have any prefab that I'm referenced to, then there's something wrong here. I would just break anyway, so we got to pause. But then we eventually go to this populate group. And then how many, we pass in how many we're spawning. While for each one we need one, we instantiate, give this game object a name, set its parent, set it false, and add it to that pool, and we lower it. So this is interesting. This is like, you could do a for loop for each like number of needs. You could loop through, say if need was 5, we would loop through here 5 times, but you could also do a while loop. You just like subtract it down. So 5, go again, 4, go again, 3, go again, 2, go again. So they're using a while loop like a for loop. So it's interesting to see that you could do things in different ways. But it's basically creating an element for each pool. So that's actually a really good ending point. So pool initializer, kind of like your pool manager. We have 6 pools that we'll be managing. Each one is referencing a scriptable object, scriptable asset. Each scriptable asset you can create up here, and somebody has created it, right? And you say how many do you want to create at start, how many extra when we run out, how do we know we can reuse, and what's the prefab that we're actually creating. And these are asset files or scriptable asset files, and you write them. It's just they're not inheriting from mono behavior, they're inheriting from scriptable objects. They're not meant to be a component object in the game. They're meant to like live outside the game. They're meant to live in your assets to be referenced. They're code that you can reference and call, but they're kind of just like sitting in your assets, not in game. And they're super useful for designers to like set up and tweak stuff. All right. And with that, I'll call it a day. Appreciate you taking the class. Fill out the student reviews, class reviews if you get a moment. Appreciate that. And hope you had a good semester. I hope you took something away. I hope you understand code in Unity a little bit more. And this Thursday is the quiz. I'm going to stop recording.